Hello, folks. Moving on to chapter 9. The first section, actually, this whole chapter, is based off of something called polar coordinates. So, just as a recap, you are used to something called Cartesian coordinates. So, whether or not you've actually heard that word before in reference to this type of plane, this plane allows us to graph Cartesian coordinates, meaning like if I graph this red point here, it would be in the form xy. So that means we always start at the origin, which has the coordinate 0, 0. Then x means, we go to the left or to the right. It could be positive or negative. Y means we could go up or down, positive or negative. And then ta-da, we end up having that red point. So Cartesian coordinates are very, I want to say rigid. Polar coordinates are a little bit different. You can kind of think of, it's not really a globe because it is two-dimensional, but it's based off of our unit circle. So the unit circle is coming back here. Now, we're not exactly doing the same type of algebra that we were doing, but visually, we're going to be using the unit circle a little bit differently. So let's get to it. In a polar coordinate system, a fixed point O is not only called the origin, that one's kind of the obvious one, but in this case, it's also called the pole. Okay, so our origin here, let's actually write it on the graph as well. The pole is called O. The polar axis, so we don't really have an x and a y axis anymore. We have what is called a polar axis. Is usually a horizontal ray directed toward the right from the pole. So, it's kind of like that angle and standard position. So perhaps let's call this point here x. Then it's represented by, for that ray, it would be ray OX. Now the location of a point P, so let's call this point over here, somewhere in that region, point P. Now that point P, instead of having an x and a y coordinate, we have the variables r and theta. Okay, now r is kind of like radius. Okay, and I say kind of, you understand here in a second why just kind of and not everything. And then theta is definitely the angle, which you're kind of used to. The distance from the pole to a point is the absolute value of r. So this statement right here implies sometimes r is less than 0, right? If I'm giving a definition of what the distance is as an absolute value, that means r can be 0. So that's why radius in geometry is always positive, because distance is always positive, and the measurement of a circle is always positive. But in these cases, r can be negative. So I don't really want you to think that that's necessarily radius, and we'll explain what that means in a little bit. And then, of course, the measure of the angle formed is where theta comes into play, and that does hold the same meaning as theta that we've been talking about in the other chapters, to the opening of the angle between the x-axis, or in this case the polar axis, and the terminal side. Okay, so now let's talk more about the variable r. So like we said, we have two options. R could be positive, and if that's the case, then theta is the measure of any angle in standard position that has ray OP as its terminal side. A little sketch of what this looks like would be, of course, O is our pole, our origin. And then if this is in standard position out to the right, let's put point P on the terminal side here. And we know that point P has coordinates R and theta. So if this is the case, if R is positive, then theta is this angle that opens up here. It's very, very typical. If R is negative, then theta is the measure of any angle that has the ray opposite ray OP as its terminal side. So this one's a little bit different. I can still have an angle starting in standard position this way, and let's just say this time point P is down here with the coordinates r, theta. Now r stands for any kind of variable, so I don't have to negate it here. R can be any number that I want it to be. So I'm now supposing, what if I plug in a negative number here for r? What this is saying is that theta is not this angle here. Okay, theta is going to be the angle that is opposite of the ray. So the ray where P is, and again, this is our pole O, opposite means you're going to go directly through the origin to the other side to make a straight line, and then this part here is theta. That's where it opens up. Now, if you're royally confused, don't fret. I think this gets a lot easier when we actually do examples with numbers and you're not just talking about the variables r and theta. So hang tight there. Now let's talk about theta. It can also be positive or negative. This we've dealt with before. If we have positive angles on the unit circle, if I ask you, where a positive 60 degree is, then that means we start in standard position, which is 0 degrees, and we move counterclockwise. Counterclockwise is the typical direction, in this case positive, and then of course if theta is negative, then we move clockwise from the standard position to graph. So I have 6 examples here of us just trying to graph points on a polar coordinate plane. So in the same way that I could ask you to graph a bunch of different points on the x and y axis, I'm now just asking you to graph them on the polar plane. So number 1, point A, it's at 2, 120 degrees. So remember, this is r, and this is theta. Now, mentality-wise, I think it kind of depends on how your brain works. I'm going to recommend that you kind of go backwards. So I personally like to find the angle first, because those numbers are, kind of a lot less, so to speak. And you'll see why in a minute. So 120 degrees is this angle here. Okay, so that means at 120 degrees, r, which is kind of like radius, right, is 2. So if r is 2, that means my opening, or I'm going to start here at the pole, and then I'm going to go 2 rings in the direction of 120 degrees. So this would be the first ring, and then the bigger point that I've graphed would be the second ring. So that would be r is equal to 2. So this would be point A. Now, we're not graphing angles, we're not graphing vectors or anything like that. That's just the point A on the coordinate plane. Notice if I tried to do an x and a y that was very rigid, right, that used 90-degree angles, if I tried to find what numbers these were, that wouldn't really, be very appropriate, because I have no idea of telling what numbers those are in a Cartesian coordinate plane. But on the unit circle, these numbers make perfect sense. Number 2, point H. This time, notice I don't have degrees. So on a polar plane, just like the unit circle, we can have our angles in terms of degrees, or in this case, like number 2, we have them in radians. Now, you do basically the same game plan. So this time I want to find, again, I want to find the angle first, negative pi over 2. Now, if this direction, so from 0, if this is a positive pi over 2, which again is the same thing as 90 degrees, then we're going to go that same distance, but in the clockwise direction to get the negative pi over 2. Okay, so negative pi over 2 is the same thing as 3 pi over 2. So we know we're starting at this angle. And then if r is 4, then that means from the pole, I'm going to go out 1, 2, 3, 4. So down here, that's the point H. Number 3, the point D is at negative 3, 7 pi over 6. So again, we're going to start with the angle first. We'll start with theta. Theta is at 7 pi over 6, so that's a positive angle. So again, if I start at 0, I'm just going to go counterclockwise until I see 7 pi over 6. So I know I'm on that angle for theta. And then notice there's a difference here. The radius, and again, I hate to use the word radius, let me use r, is negative. So what this means is, if r were positive, don't draw this, if r were positive at 7 pi over 6, this would be the point. This would be a positive 3 from the pole in the direction of 7 pi over 6. But it's not a positive 3, it's a negative 3. So what that means is you're going to go through the pole to the direct opposite ray of 7 pi over 6, and you're going to go 3 in that direction. So again, maybe you want to highlight the entire segment that represents, it didn't do a great job there. Let me try that again. 7 pi to 6 over here to pi over 6. Like if we did a bow tie, that would be, 2 parts of the triangle there. Okay, so instead of going a 3 in the direction of 7 pi over 6 from the pole, we're going to go 3 in the opposite direction. So this would be considered negative 3 in the direction 7 pi over 6. Okay, so your answer, I'm going to erase all of mine here in a second, but this is here so that you understand. Your answer is this big black point here. That is point, well, I think I've erased it. That is point D. This point over here to the left would be if it were positive. So let's try another one like that, except this time this is in degrees. So I have point T, it's at negative 2, 315 degrees. So let's do one thing at a time. Let's first find the angle. So positive 315 degrees. Notice it's not written on the unit circle. Okay, so you have to use what you remember about the unit circle to figure out where 315 degrees should be. Well, obviously it's going to be smack dab in the middle of 300 and 330. So there's our 315 degree angle. So I know my point's going to be along this. That's like the 45 degree angles of the quadrants. So I know it's going to go from 315 to whatever this angle is, opposite of it, just like that. Okay, so instead of from the pole going positive 2 into the direction of 315 degrees, I'm going to go negative 2 in the opposite direction, in the direction of 135 degrees. Okay, so this is the point right here. This is the point T. And you don't have to do this every time, the positive 2, negative 2. I'm just trying to show you the difference between if the number said was positive versus negative. And obviously these are the more challenging ones where you have a negative r, so that's why I'm practicing those mainly. Okay, number 5. Okay, let's again start the angle. It's negative pi over 3 is my angle. Well, if you have a hard time envisioning where negative pi over 3 is, look first at the positive version of pi over 3. So if positive pi over 3 is here, then negative pi over 3 is actually the same thing as 5 pi over 3. Okay, so there's my angle. And then again, since r is negative, I'm actually going to be going across the pole into the opposite direction. So instead of starting at the pole, moving 3 into the direction of 5 pi over 3, I'm going to be moving 3 in the opposite direction. And there's point B. Last one, point S. R is negative 4. Theta is 0 degrees. Well, this one's easy. Theta is 0. And then if it's at negative 4, that means instead of at the pole, so now we have our polar axis. So instead of going from the pole 4 in the direction of that 0 degrees, we're going 4 in the opposite direction. And then there we have point S. Okay, so we'll talk a little bit more about the difference in these points and kind of the not uniqueness about them in terms of the numbers. Let's do a different type of question. Number 7, I want you to find the polar coordinates for point B. If point O is the pole and ray OX is the polar axis, assume O is the midpoint of AC. Okay, so we have a few different pieces of information given, and of course, lots more drawn in the picture. So basically, here's what we got going on. O is the pole. O to X is, they said, the polar axis, which means this is 0 degrees. So our goal is to figure out what are the coordinates of point B. What are the coordinates of point B? In other words, how do I graph that? To graph that, I need R and I need theta. Okay, so again, R represents, and again, I hate to use the word magnitude because magnitude is length, which is always positive, but magnitude is also represented as the absolute value of the pole to the point. So if I'm going to find R, I literally just need this distance here from O to B. That is R. And then theta is going to be the angle created between the polar axis and R. Okay, so what we're going to do is if we draw in a right triangle, so if I drop this altitude right here, and if that's a right angle, if this length over here is 12 feet, and I know that this little red altitude is 6 feet, because it said that O is the midpoint of AC, so if those are congruent to each other, and then those parts were congruent, then that means that that red altitude is 6 as well. And then that means this bottom part is 18. Well, hopefully you realize that we can just use the Pythagorean theorem to find our radius. So if I do 6 squared plus 18 squared equals R squared, then I get R is equal to, I'm going to do this kind of all in one step. This is going to be the square root of 360 degrees. Now, if you're not thinking ahead, you'll understand later. We're just going to round everything to the nearest whole number. So typically, I like things in simplified radicals, but we'll round to the nearest whole number. So if you take the square root of 360, it's going to round up. You're going to get that R is approximately 19 feet. So we'll hold on to that. So that takes care of R. And then the second coordinate is theta. Well, this is where you needed to think ahead. If you look at that triangle, and if you set up the tangent ratio, the tangent of theta is the same thing as opposite over adjacent, which is going to be 6 over 18. So if I want to isolate theta, then theta is going to equal the tangent inverse, or arctangent, of 6 over 18. So on your calculator, make sure you're in degree mode, even though it doesn't specify. When in doubt, answer in degree mode. And then you'll hit second tangent, you're going to get that theta, again, to the nearest degree is approximately 18 degrees. So finding the polar coordinates for point B is going to be R is 19, and theta is 18 degrees. Typically, you don't put feet or those types of measurement units in your coordinate, but putting the degrees is standard. In fact, putting the degrees helps us differentiate between whether or not we're talking about degrees or radians. Okay, last type of thing to discuss is remembering that every angle on the unit circle has an infinite amount of coterminal angles. So the unit circle is between 0 and 360, or in radians 0 to 2 pi, but we could continue going around and around and around and around the unit circle in terms of continuing to add degrees or subtract degrees off of our initial starting point. So for instance, I want you to name 3 angles that are coterminal with 10 degrees. Well, the obvious thing to do with that might be to just take 10 and add 360 to it. So if you do that, if we just add 360, then we get 370 degrees. So those 2 angles are coterminal. They end up in the same spot. Additionally, we could subtract 360 from both, at which point we would get, or from 10, which we would get negative 350 degrees. And you could continue doing this in both directions. I could keep subtracting 360, I could keep adding 360. So again, if I add 360 to 370, then I'll get 730 degrees. And if I add 360 to that, then I'll get another 1090 degrees. And you could do, again, there are an infinite amount of answers here. So this is just, I actually named 4, but you only needed 3. Anyway, you get the point. Keep adding 360, keep subtracting 360, or if I gave you radians, you would do multiples of 2 pi. So in these cases, number 8 says, name 4 different pairs of polar coordinates that represent point S with the restriction of theta being between negative 360 and 360 degrees. This should have a degree symbol. Okay, that being said, let's first kind of find the obvious coordinate for this one. We're going to go backwards. All these other ones you were graphing, I gave you the point, you had to graph it. Now I'm giving you the graph and you need to go backwards. So the first thing that we did was determine the angle, right? We went backwards. So if I look at this picture and I determine the angle, point S is aligned with the angle 150 degrees. From the pole in the direction of 150, it has R equal to 3. Okay, so that's one. That's probably the most obvious name for that pair of polar coordinates is 3, 150 degrees. But there are actually an infinite amount of answers because I could keep spinning 150 degrees over and over and over and over and over again and keep landing at that same point. Now, I did give you a restriction of your answers being between negative 360 and positive 360. So at 150, if I added 360, I'm going to be above my restriction. So let's try subtracting 360. If I take 360, or 150, so this is one answer, 150 minus 360. So in other words, what's happening here is instead of starting at 0 and going to 150 degrees here, what if I went the other direction? You know, what is going counterclockwise? How much would it take to get to that point? And that would be 180. No, lies. That would be 210? Yeah, that'd be 210 degrees. So that's another way to write 150 degrees is as 210. So that's another point for S. 3, still a distance of 3, but 210 degrees. Or negative 210, rather. Okay, so negative 210 to 3. Now, those are probably the obvious answers. The not obvious answers are, well, what if we didn't go an R of positive 3? But what if R was negative 3? So that means from the origin, if we do negative 3, that means we're going 3 in the opposite direction. So this is negative 3, landing us now at the angle 330. So that's another representation of that point. I could go 330 degrees, but I can go negative 3. So now let me erase some of this and kind of explain what that means. If I start at 330 degrees, if I start at this angle, and I go in the direction of negative 3, that means from the origin, instead of going 3 in this direction, I want to go 3 in the opposite direction. Bam, getting me point S. So 330 negative 3 is another version of that point. And then again, I could use the negative, but instead of 330 degrees, I can represent that angle. So 330 is what happens when we go in our typical direction of counterclockwise. This is 330 degrees. But how can I get to that angle going the other direction? What is that angle going clockwise, that's going to be negative 30 degrees. And that's our last answer. So these are interesting questions because we're used to, on the Cartesian coordinate plane, every point having a, one unique location. But the reality is, on a polar plane, between negative 360 and positive 360, there are 4 answers. And if I don't limit you, if I don't give you a restriction, there are an infinite amount of answers. Similar question. Point J has coordinates negative 2, negative 120. Name 3 other pairs. Again, I'm limiting you only to between negative and positive 360 degrees. So first thing, let's go ahead and graph where this point is. Sometimes it's a lot easier to see it. Okay, we're going to graph it in the similar ways that we've done so far. First, let's locate the angle. Well, if you have a hard time envisioning where negative 120 is, let's look at where positive 120 is. If that's positive 120 degrees, then negative is going to go the same distance wrapped around, but in the other direction. So negative 120 degrees is the same thing as the angle 210, which is one of our first clues. Okay, so that being said, from this 210, we are going an r of negative 2. So that doesn't mean from the origin in the direction of 210. Whoa, I messed this up. Okay, I knew I had something a little crazy going on here. I'm sorry, I looked at the wrong thing. If we're looking at our bow ties, it says 120. It's going to be 240. Ooh, it's too late. Okay, so 240 is our angle here. So from 240, I'm going a direction of negative 2. So instead of going 2 toward 240, I'm going to go 2 in the opposite direction. It's going to be right here. So this black dot is point J. So let me kind of erase some of the other stuff we had going on here. Now, like I said earlier, 240 is actually one of our clues, because instead of writing it as negative 2, negative 120, I can easily write point J as, instead of negative 120 degrees, that's the same thing as 240. So I could do negative 2, 240 degrees. Okay, and then the other answers are actually a little bit easier. If I just looked at point J in the positive realm, starting at 0 degrees, it's lying on 60 degrees, and it's got a positive, because it's in the same direction, positive 2. Okay, and then 60 degrees is the same thing as if I went the other direction all the way around the circle. If I subtracted 360 from that, I'd get that J is also 2 negative 300 degrees. Okay, these are kind of tricky questions, but you'll get better at them also once you kind of see the pattern. There's always, in between 360 and negative 360, there will always be 2 positive R's, 2 negative R's, and the other numbers are like coterminal angles, just like we found these. Okay, last types of questions. I want you to graph the following polar equations on the coordinate planes below. Number 10 is R equals 3. So I want you to think about what this means. I want you to think about all of the coordinates that you could possibly graph that would have the R value equal to 3. So let's kind of start basic. If I looked at 0 degrees, so if I started, 0 in my angle, and this would be the coordinates R of 3, oh, it's in radians, so R of 3, angle would be 0. Well, let's look over here. What if I chose a different angle? What if my angle was 2 pi over 3, and this time R was 3 as well? So now I'm on this angle, but this part is here. So again, still 3 from the pole in the direction of that angle. And again, I could do the same thing. I could, from the pole, go 3 in this direction of the angle, 3 pi over 2. So what's going on here is there are an infinite amount of points, or an infinite amount of angles that could also have an r of 3, which is actually what creates a circle. So in this case, it is kind of neat to think about r as your radius, because all of these points create the circle that would have a radius of 3. Again, so these are 3 specific points, but all the points in between also have r equals 3. Number 11, where is theta equal to 150 degrees? Well, 150 is this angle here. So if I pick a bunch of coordinates, r stands for the distance that you count from the pole. So I could count, or I could kind of open up an angle from 0 degrees and open up here to 150. So this point would have the coordinates 150 degrees. This one would have the coordinate 150 degrees. And of course I can go into the negative realm as well, right? Like what if I open it this way? And this one have 150 degrees, but what if I went into the negative direction? So it's -3. So the point is, all of these theta values will be 150. And if I graphed a bunch more, they would actually be the line that goes through the pole, and that opens up to 150 degrees. Okay, last one. R is equal to -2. So this is where thinking of r as radius gets confusing, because you're like, well, how do I have a radius of -2? Well, again, let's start at 0. If I start at 0 degrees, instead of counting 2 in the positive direction to 0, when it's negative, that means you go in the opposite direction. So this coordinate here would be -2, 0. And then if I chose a different one, perhaps just straight down, this one would have the coordinates pi over 2, right? If I opened up pi over 2 and then again went downward through the origin to graph -2. So -2 pi over 2. And again, I could graph a bunch, but to try to not make this question even longer, in this case, it almost is the same thing as also having a radius of +2, because that negative just shoots all of these points directly through the origin to the opposite side. So that one would be like a circle of a radius 2 as well. So here's your intro to polar coordinates. It is extremely important that you are very comfortable with the unit circle, that you are comfortable, especially when r is negative. I think that's the tricky part.